Okay, in this problem, whenever you're solving an equation with rational exponents, you want to make sure that the bases are the same, which they are. There's 7. And then you want to see if there's any properties to be had, which the only properties we know right now are multiplying and dividing. When you multiply the same bases, you add the exponents. When you divide them, you minus the exponents. So here, it just becomes the exponent equals the right-hand exponent. You want to draw your wall. I always choose the x first. You don't have to. You have to do the inverse operation, which is minusing 4x. And now we have a two-step equation. So then we have negative 1x equals 4. And then we have to undo multiplying by dividing. So then we have x equals negative 4. For this slide, once again, we have the same bases. There are no properties. There's no multiplying by the bases, and there is no dividing by the bases. So you have to set up the left-hand side exponent equals the right side. Now this one is slightly different because you have to distribute first. The biggest mistake I saw in class today, students forgot to distribute 3 times 1. So I'm just going to prove a point. You are allowed to undo something other than the 6x first. But when you undo something different, you need to remind yourself that now the two-step is on the right-hand side. So we're not allowed to combine like terms or move things around that we normally would. We would still have to undo. So for this example, I still have x's over here and x's over here. So I have to minus 6x on both sides. So then I have negative 4x equals 8. And then I have to undo dividing by negative 4. So then I would get x equals negative 2. Slide number 8, be mindful. Anything that doesn't have an exponent written has an exponent of 1. So we can do 6x minus 2 equals 1. So now this is just a two-step. The calculator will always simplify a fraction for you. So 3 over 6 is really 1 over 2. Number 9, we finally have a property being used. We need to add the exponents together. And then it equals the 7. So combine like terms, we get 6x. Combine the 3 minus 6, which is negative 3. Then we can add 3 on both sides. Now you do want to simplify. 10 over 6 becomes 5 over 3. So please be mindful that you always have to simplify. Number 10, students have been tripped up on. This is the second one where when you are dividing same base, you need to minus. So my first exponent in the numerator is 9x minus 8. My second exponent is 4x plus 2. And my third exponent is 6x minus 4. Now this division right here means I have to subtract the exponent. However, we have an exponent that is 2 terms, so you do need to use parentheses around all the purple. So you want to distribute a negative 1, so that's going to make the parenthesis or the second exponent everything the opposite. Now I can drop down the numerator exponent and then equals the third exponent. Draw your wall so you can see it clearly. 9x minus 4x gets you 5x. Negative 8 minus 2 is negative 10. Now, once again, it becomes a problem like before where we have variables on both sides. So then we're going to minus 6x. So then you have a two-step. And then divide by -1, you have x equals -6. Number 11, slide 11, we are multiplying here, so we have to add the exponents. Drop down the equal sign, and then the last exponent is 11. We can combine like terms. We have 7x plus 4 equals 11, minus 4 on both sides. And then we're going to divide. Slide 12, this was a challenge question. The base would be 7. So 49 would be 7 squared, but it already has an exponent of 2x plus 3. 343 is in 7 to the third power, but it already has an exponent, so you just use parentheses. And then now that they have the same base, you can write down the exponents as part of the problem, distribute, and now it becomes a problem like we're used to. I prefer minusing 3x on both sides. I get 1x plus 6 equals 18, and then minus 6, I get 1x equals 12. You can keep it like that or divide by 1. It's truly up to you. It's the same. Now for the rest of the slides, you just have to be mindful use of radicals. When you are typing, you want to use the nth. So the exponent, that's the denominator, which is 3, goes in the root, and then 4 raised to the 5th power. Same with this one, you need the nth root, so then 4, the base stays raised to the -3. Here you have to make sure that you hit the buttons correctly. You want to put the base first, then you want to do a to the b, and then a over b to get the positioning correctly. -3 over 4 should be in the exponent. 16, please remember if there is no exponent, like for example next to the 5, it's really a 1. So it's 1 over 3 as an exponent. Here we have x as the base raised to the 2 over 7. And then please make sure that you fill out this slide. And then slide 19, you want to make sure that you upload your work.